Cross and integer matrix, correct? There are integer matrix max level of size and administer such that max level of ij is equal to the largest value of the 3 cross 3 matrix in grid centered around row I plus 1 and column j plus 1. Generated matrix 9 9. Hmm. So this segment में it's 9, this segment it's 9. Okay. So in this segment it's 9. In this segment it's 9. In this segment it's 8. In this segment it's 6. That would be like 1 2 3 4 into 3 12. So this is more of a brute force. 25. 1 2. Oh, okay. Huh. That's 1 2 3. That's it. Hmm. So I can say the row number is initially 0, column number is initially uh, column number will change. So let's have this. So row I can have, okay, let's n is the number of rows here. Should be great. And make the number of columns. Mm-hmm. Hmm. While row is less than while row is less than n minus 3. Huh. So let's say row is 0. Here n is 1, 2, 3, 4. 4 minus 3 is 1. So while 0 is less than 1, while 1 is less than 1, no. So there should be while n row is less than equivalent to n minus 3. 0, अच्छा 1, 2, 3, 4, 5. 5 minus 3 is 2. 0, 1, 2. यहाँ तक के लिए चलेगा, right? So my end row would be what? My end row would be probably row plus 3 because I'll go 3 steps forward. 0, 1, 2, 0, 3 हो जाएगा, right? हाँ, ठीक है. Now I have to loop in this thing. Now my end column would be whatever this thing would be, which is um, column initially 0. Okay, so for each and every row, मैं column में आगे बढ़ूंगा. Maybe I can do that. हाँ. Hmm. So I can say this now. Mm, I'll go to because for example n minus 3 is n is 4 minus 3 is 1, so 0 के लिए चलेगा but 1 के लिए नहीं चलेगा, so this should be probably n minus 2. That's it, n minus 2 as well. Column is 0, 1 तक के लिए चलेगा but at 2 it will stop. Yes, 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 yes. Now simply so what's my row ended? That's I plus 3. The column is going to end at k plus 3. Again I'll have something like row is 0, or let's say row is I, column is j, max value is initially let's say it's 0. If I can simply say, like simply loop in this, so for I can do this for row in range of, I'll go from I, which is current, till I plus 3. Makes sense. And then for column, I'll go in this way from j till my max value, the maximum of max value, and whatever grid of row and column holds. So I don't even need to have this. once I have the max value, what I can do here is कि पहले रो के वैल्यूज मिल गए, I mean पहले कॉलम के वैल्यूज मिल गए. So कहते हैं my answer is this, and let's say my 10 is this. So basically I'll say 10 oops 10 dot and then here I can say answer dot assign whatever this 10 is. Once done, I can simply return the answer. Run code 9986. I'll submit this. Accept. Done. Node with highest edge score. I'll turn off the music. Node with highest edge score. You are given a directed graph with n nodes labeled from 0 to n minus 1. You are given a directed graph with n nodes. You are given a directed graph, okay, with n nodes labeled from 0 to n minus 1, where each node has exactly one outgoing edge, where each node has exactly one outgoing edge. The graph is represented by a given zero index integer array, edges of length n. The graph is represented by a given zero index integer array, edges of length n. Where edges of I is this related is from node I2, that means node edges of I. So from 0 I can have h2, 1, 2, 3, 4 and so on. The edge score of a node I is defined as the sum of the labels of all the nodes that have an edge I pointing to I. Sum of the labels of all the nodes that have an edge pointing to I. Acha. Return the node with the highest edge score. If multiple nodes have the same edge score, return the node with the smallest index. So lexicographically, answer J is correct. So for example, in this case, I just need to understand this thing. The edge score of a node I is defined as the sum of the labels of all the nodes that have an edge pointing to I. So I का edge score क्या हो गया? Let's say 2 and 5 is pointing to I, so that will be 7, right? So I have to print or return the node with the highest edge score. So for example, in this case, what I can defer is key. There's an edge from 0 to 1. Makes sense. There's an edge from 1 to 0. There's an edge from 2 to 0. Yes. There's an edge from 3 to 0. There's an edge from 4 to 0. But this can be disconnected graph as well. So connected graph, but it can be disconnected as well. So okay, disconnected graph हो सकता है ना. So 1 2 0 1 2 3 4 5. So 5 to 7 there's an edge. 6 to 7 there's an edge. 7 to 5 there's an edge. Okay, cycle भी हो सकता है. Okay, the nodes 1 2 3 4 have an edge out pointing to node 0. The edge score of node 0 is 1 plus 2 plus 3 plus 4, which is 10. The node 0 has an edge pointing to node 1, therefore 1 का edge score is 0. Then 2 and 3 and 4 का कुछ edge score है ही नहीं because there's no node pointing to them. And then node 7 का edge score क्या हो जाएगा? 11, right? Node 7 is pointing to 12. The edge score of node 5 is 7. But 7 का एक 11 हो जाएगा, please. हाँ 11. And then 6 का nothing. So I think so the highest answer here is edge score यहाँ पे 10 आया, 11 आया, 0 आया और 7 आया, तो 11 is the answer. Hence I could return not the edge score but the node which has the highest edge score, which in this case is 7. Okay. इसमें क्या हो जाएगा? 2 का आंसर क्या है? 3. इसका आंसर क्या है? 3. So I have to return 0 because 0 is the smallest of 0 and 2. N is 10 to the power 5. Sense n is 10 to the power 5. Which is a 5, blah blah blah, and is a 5 and is a 5 inches. So I need to compute this in a very smart fashion because so if I have a node from 0 to 1, which means my 1 पे answer हो जाएगा. That's it, right? That's it. Okay. So I can say क्या हो गया? What happened? Okay. Then it is on. Let's say edge course is initially let's say hash map. Um, yeah, you can have it as a hash map. That's not a problem at all. So, by the way, I can initialize this as follows. Edges is probably that thing, right? So I have that like this. I can say n is, I can say number of nodes like this, whatever the length of edges is done. So I can say node, but again, it's going to be empty for node range. Whatever whatever that this node is done. And also one more thing. It's a 0, 1, 2, 3. So it's not one based indexing, but zero based indexing. Right. Okay. I don't think so. This is okay. So what I can do next? I can just loop over these edges. So for range nodes, I can say current starting. Let's say my start node is probably and is. So I'm going from start to end mode. I'll demonstrate that. It will be so I'm saying that we are doing this fraction, which is add set which will be probably edge scores. And we will add whatever the start meta value is. Once we are done with this, I'll sort the edge scores, right? So I can say max edge score is probably commencing all the values, which will be edge scores. And now I'll see the possible, let's see, answer is possible answer. I can say possible nodes can be basically I'm taking a list here. So I'll loop here. So for edge scores, I'll say okay, edge scores, edge scores, equivalent to the edge scores. In that case, SQL nodes and whatever the node is. At the end of the day, I have to stop it. This should be possible. Nodes. So this is and now I can enter it on zero. Run the code. 7 and 7. Let's submit this. Accepted. Basic as so I have the information here. I just simply take it and utilize it. Done. This one's done. Construct smallest number from di string. You are given a zero indexed string pattern of length n consisting of the characters I, meaning increasing, and d, meaning decreasing. Zero indexed string pattern of length n, acha, consisting of the characters I, meaning increasing, and d, meaning decreasing. A zero string of length n plus one stated with the following conditions. Num consists of the digits 1 to 9, where each digit is used at most once. Okay. Hmm. If pattern of I is I, number of I should be less than number of I plus 1, and if pattern of I is D, then okay. For the smallest possible string num that meets the conditions. Okay. Hmm. I means increasing, so 1, 2, 3, then decreasing, so 1, 2, then 2 ke liye 3 will come, and then so 3, 3 say maybe I could have 4, but 4 cannot be one of the possible answers. Hence I have 5 here. Okay. And then 5, 4 is decreasing, 4, and then let's say 6 is increasing. But 6 के साथ decrease I cannot do, right? So 4 के साथ I have to do something like 9 and so on. So if it's increasing, I go with all the values. Hmm. If it's increasing, then I go simply 1, 2, 3, 4, 5, 6. But let's say decreasing twice, right? So let's open up the whiteboard. How do I clear this? So let's say increasing, 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 but there's twice decreasing and then again increasing. So what will be the answer for this? Increasing, right? So 1, 2, basically 2, 3, basically 3. See, I cannot simply have 4 because it's increasing, but I have to take care of how many D's are there. I see there are 2 D's. So what I'll do is I'll increase the value by current last value was 3. So I'll go with 3 plus whatever the number of D's are plus 1. 6. I'll go with 6. So I'll have 6 here, then 5. Then 5 case automatically 4 will come. Now this 4 can be paired up with increasing order, right? So 1, 2, 3, 4, 5, 6, 7 will come. That's it. 1, 2, 3, 4, 5, 6, 7, 8. There should be 9. 9. Makes sense. Also, this is decreasing, right? 6, 5, 4 ke sath 7. Maybe the answer is very simple. TDT. Okay. Okay. What if the answer follows this pattern? I simply write all of these numbers, and then what I'll do is I find कि first 3 spots में सही है DD, so I reverse this, then I follows. Or maybe I reverse these 3 because DD is there, so I'll consider these 3. So whenever I encounter a D, I'm like, okay, do me a favor. From that on point onwards, एक I ले लो and then increase it. So like 1, 2, 3, 4, 5, 6, 7. I. T आया. So take this as well. So reverse. So 6, 5, 4. then I is there, so simply go ahead. Uh, hmm. So the idea is as follows. My number would be simply, what would it be? Let's say 70. So I can say for I uh, till say the length of the pattern is, let's say n plus 1. So I can simply say number plus equivalent to str of I. So 1 till whatever the thing is. So in this case, n is probably 1, 2, 3, 4, 5, 6, 7, 8. From total 9. So n plus 2. Yeah, plus 2. Done. So this is going to be till 9. And then I have to modify this. Hmm. What I can say here is, let's say it's index is 0, or better would be number. Hmm. I'll do this way. Mhm. C can be, or we can say take up the segment of these plus 1, simply reverse it. So I can say my start point is whatever the heck this idx is, while idx plus 1 is, or I can simply say while idx plus 1 pattern of idx is equivalent to, in that case, I can simply say idx plus equivalent to 1, and the count of these is 0. So yeah, they're doing the same thing. So I simply say count of t is greater than 0, which means I have to consider it. Or I can say in this, and it will go forward. Let's say count of these becomes 2. Once, twice, but it's not no more there. So 2 is something I got, and will be 1 more than that. Okay, and will be probably start plus count of these. So start was at, let's say, 0. So 0 plus 2 is 2, which is this thing. It's fine. So I don't need this extra one. So I'm going to say simply reverse the segment starting from, what do we say? Start till, something I can do. So that would look something like this for saving, or so the starting, start, end. Should I do, no? So while let's just mix them into that, I can say in the number at the S location, just simply drop it with the at the end location, reason do this, and we are good to go. At the end of the day, I just simply return this, but I want add an empty number as well. That's it. Run code, runtime error, okay. Number step n plus 2. Okay, n is not defined now. So n is nothing but the length of the line. I've already written it, but it's written below. Now that's done. Run code. 1, 2, 3, 4, 5, 6, 7, 8, 9. 3, 4, 5, 6, 7, 8, 9. This is not what I am expecting. Okay, so IDX will become, see, this else part will come here. Else my, in this case, IDX will become, it will go to that place, no? County. So it has processed all of these things. And then also it's fine, right? Acha, I'm not increasing the counties. I see. This is fine. Okay, so I have to increase this here. Now it will be good. 1, 2, 3, 4, 5, 4, 9, 8, 7, 6. Done. This should probably work. Accepted. Okay. Count special integers. We call a positive integer special if all of its digits are distinct. We call a positive integer special if all of its digits are distinct. Let's say 1, 2, 3, 4 is a special number, right? Because all of its digits are distinct. But if the number is 1, 2, 3, 3, it's not um, distinct and hence it's not a special. So to count special integers, given a positive integer n, return the number of special integers that belong to the interval 1 to 1. Okay, and n is 2 dot 10 to the power 9. Okay, this is from 120, except 11 are special. Thus, there are 19 special integers. Okay, let's try other way. What if I was special is? I can't just simply loop from 1 till n and get the answer. No, we are TLE. This is number 20, right? So I have to go from 1 till 20. I know 11 is going to be problematic. How do I determine this? Let's say the numbers given are at this, right? So the number is 123. I know that if I start from here, there's nothing before it. So I know at this first place, I'll get 10 numbers. No, not really 10 numbers, but like is zero required here? I mean, 1, 2, 3, 4, 5. No, zero is not a thing here. 1 till n. Na. So in this segment, what can I get? I can get 1, 2, 3, 4, 5, 6, 7, 8, and 9, right? Yeah. So I can have possibly 9 numbers from this segment. So answer to this is 9. When I come here, I know still there is something here, so I can go till 99, right? So what are all the numbers I can include here? But I know uh, it's going to be problematic. So in this case, I can have 9 numbers total. Here I can have probably not 99, but I can have 90 because 9 are included already. Yeah. So 1 till 100, that's 100 numbers. But excluding 1, that's 99 numbers, but 9 already taken, so that's 90 numbers remaining. So out of 90 numbers, how many can I not have? Out of 90 numbers, I cannot have 1, 11, sorry. Uh, I cannot have 22, I cannot have 33, I cannot have 44, I cannot have 55, I cannot have 66, I cannot have 77, 88, and I guess 99 as well. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. So minus 9, that will be 81. Let's say this was 135. So here I can have 81, I can have 9. What about this place? So this is 1. I know. How many numbers can I have here? I know I cannot have something like 1, 1, 101. I cannot have 1, 1, 1. and anything related to 1 1. So 1 1 2, 1 1 3, 1 4, 1 1 5. I cannot have all of these guys. How do I determine this? Because so what are the numbers I cannot have from 100 till 135? They are like 100 I cannot have. I cannot have 101, 102, 3, 4, 5, 6, 7, 8, 9, 10. 110 I cannot have. 111 I cannot have. 113, 114, 115, 116, 117, 118 I cannot have. 120 I can have. 121 I cannot have. 122 I cannot have. This was 125. 123 I can have. 124 I can have. 125 I can have. So only these things. Hmm. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 14 I cannot have. How do I determine this number? Notice if it's 1 at this place, I cannot automatically have this one place here. Automatically that removes 10 possible answers, which is this segment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 7, 8, 9, 10. Yeah, 10 possible answers are excluded from there. And for this, again, 10 possible answers will be excluded. Why? I cannot have 101, right? I cannot have 111. I cannot have 121. I cannot have 131. I cannot have 141. I cannot have 151. I cannot have 161, 171, 181, 191. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 possible answers excluded. Can't think. Let's have a look at discuss for this one. Digit DB. Hmm. Let's go with Python. I want to see the transform n plus 1 to array list. Count the number digits less than. Count the number with same index. Okay. For example, if n is 8765, so let's just basically 8766 plus 1 to array list. Great. Count the number with digits less than n. Number without repeated digit can be the following format: triple x, xx, and x. So 1xx, 7xx, 8086, 870. Okay. So I simply 8766, right? So I simply go from 1000 to something like 7000. So this is still 7999. Then I'm gonna go from 80 till something like 86. Then I'll try to go from 870 till 875x. Acha, 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 acha. So he's going from 80xx to 875x and then 875 or 8760 to 8765. Not getting the thing here. Don't have any comments as well. Not getting the thing. You have to run this. Okay, I have to run this for sure. This is for 306. Let's go for 305. This Leetcode is let's do a version context. Number of arithmetic triplets. Let's put on some music as well. Number of arithmetic triplets. Okay, you are given a sequence text strictly increasing array nums and a positive integer def. The triplet ijk is an arithmetic triplet with the following prediction met I is less than j is less than k, nums of j minus nums of I is equal to difference, and nums of k minus nums of. So like basically the element of the difference, absolute difference, not absolute difference. This difference is equivalent to this difference, right? And the number of unique arithmetic triplets. Unique arithmetic triplets. And this can be, I guess, uh, brute force, right? Brute force kind of might work. Let's see. Hmm. My answer is 2. Hmm. 4, 5, 6, 7, 8, 9. Difference is 2. Okay, I'm going to use the example test because it's cool. Okay, what if this is, let's say, by the way, are they all distinct? Yeah, they are distinct. Let's submit them. It should give me a DLE, right? Hmm. Brute force is not the way. So it's more like if I'm considering 1 and 2, then automatically I need 2. Okay, so I need to run 2 for loops. And I'll check कि वो third number है कि नहीं. Okay, that's it. हाँ. Mm-hmm. So I'll keep a track of this thing, right? A set of these numbers, and I just need to run a loop like this thing, right? And now I know key number 3 would be nums of j plus difference. I just need to check if it's there or not. So if nums of j minus nums of I is equal to difference and num3 in uh, s, which is set, then triplets plus q and 1. If I'm not wrong, so run code. Let's take this now. Let's copy this. Let's paste it here. Run code. Your answer is 99. It's finished. Okay. Let's submit this. Accepted. Okay. So big of N square solution, there's a modification that I know of the number 3 in advance. Just I need to check if it's there or not in a big of 1 using this set operation. Great. Okay, good question. Close this. It's done. Reachable nodes with restrictions. Let's see. Reachable nodes with restrictions. There's an undirected tree with n nodes labeled from 0 to n minus 1 and n minus 1 edges. You're given a 2D integer array edges of rectangle minus 1, where edges of I is a of I bi. Here's there's an edge. Here's a of I and bi in the tree. So it's undirected. So I can go from a of I to b of I. More formally, I can go from a to b and b to e. You are also given an integer array restricted, which represents restricted nodes, which means maybe I cannot go there. What are the maximum number of nodes you can reach from node 0 without visiting a restricted node? Okay, so I need to reach the maximum number of nodes without even touching the restricted node. Normal DFS or BFS? Note that node 0 will not be a restricted node. That's for sure. So for example, in this case, I know for a fact that the restricted nodes are 4 and 5, so I cannot touch them. So I need to just go, like I can just simply go to see from 0 to 1 to 6. In this case, I can go from 0. It's very simple, right? Trivial. To a simple DFS or BFS, right? Yeah, I can do that. So let's create the graph first. Graph is empty. Now I'll go over the edges. So for u comma v in edges, uh, let's say if u not in graph, in that case I can say in graph of u, let's have it as empty. V not in graph. In that case I can simply say graph of v if you handle this empty. Then simply I can just do this operation graph u append v and then graph of v for append u. The reason being it's undirected, right? Or I can simply say undirected. Hence u to v and v to u. Makes sense. Okay. Graph has been created, right? And edges is also in this format. Restricted code, let's say I'll keep it as a set, just so that the accessing thing is quite faster. Now, graph has also been made. What else do I need to do? N is the number of edges now. That's 7 to 0 to 6, not 1 to 7 or 0 to 7. 7 means 0 to 6. Again, 7 means 0 to 6. So I'm saying that start a DFS or BFS from node 0. I can do any one of these. So let's say I'll do BFS. So start a BFS from node 0. Let's say I'm going to use DQ from collections or DQ from Q is for DQ. So I can say something like Q is DQ, and I can even say key in the Q. Let's keep track of listed. Which means that okay, is the node listed or not? So in listed initially I add 0 because initially we added 0 and 0 is the point. Oh my god, so it should be a comment. Done. It should be 0. Done. So I can simply say that while q, which means uh, while my q is empty, run. a new process. So I can simply say current the topmost node, and then I'll remove it. Q.popular is the option for that. It is an inbuilt one thing. So I can equal. Now what can we do? Popular has been done. Explore all the neighboring nodes from current node. So I can simply rename this as node, but also make sure to not set the restricted. So I can simply say that for for neighbor node in graph of or I can even say this key um, if current node not in whatever this thing is, right? So if current node not in, um, then it's a continue. For neighbor node in graph of current node, so I can visit these neighbor nodes, right? At the end of their system, the answer is um, max nodes we can visit, which is probably 0 at the reason being is 0 considered as one of these nodes? 3, 3, 3. Yeah, so max nodes I can visit is at the beginning itself because I can visit 0 because yeah, 0 by default. Okay. Restricted coin just made that to set UVs the edges and made the graph, and then max nodes I can reach is 1 initially because by default we can reach 0 because I'm starting a BFS at 0. Then I took the Q, visited set is something I took, while Q current node is something I'm taking. And then if current node is not a graph, then I continue, or else I can see the playlist explore it. So for neighbor node graph this, let's do it. If neighbor node not in visited, so which means it's not visited, and neighbor node not in restricted as well. So if it's not in both of these persons, I mean visited and restricted, in that case, I can probably take it to let's say the visited set, and then in the queue also I can add it. That should be queue dot append. What and also the maximum of the that's in case. End of the day I can return maximum. So that should be runtime error. Achha. Management type set string dot has string add new one. No, that's it. Finish. Answer is 4 for this. Yeah, answer is 4 for this. I'll use the example test cases. 4, 4 and 3, 4 and 3. Let's submit this. Accepted. It's not even medium, right? This is like easy. So a simple BFS from node 0 to all the nodes just to keep track of uh, uh, and then I cannot visit the restricted nodes as well. Makes sense. Okay, the system. Check if there's a valid partition. The, the let's get this one. Check if there's a valid partition of the array. This is a matter where it's going on. Check if there's a valid partition for the array. You're given a check there's a valid partition for the array. You're given a index items. You have to partition the array into one or more contiguous subarrays. So I can maybe partition it into one or more. Let's say 2, 3, 4, 100 of them. That's not matter. We call a partition of the array valid if each of the obtained subarray satisfies one of the following conditions. Okay, there's a condition for the partition as well. The subarray consists of exactly two equal elements. For example, the subarray 2, 2 is good. So I cannot have something like 2, 2, 4, 4 because there are two, sorry, two subarray consists of exactly three equal elements. For example, subarray 4, 4 is good. The subarray consists of exactly three consecutive increasing elements. That is the Acha. So 2 2 so xx is possible. Subarray consists of exactly three consecutive x increasing. So for example, subarray 3 4 5 is good, but the subarray 1 3 5 is not good. So 1 3 5 is not good, but 1 2 3 is good. Something like 3 4 5 is good. Increasing, simply increasing. Peak of the atomic array. Return true if the array has at least one valid partition. Otherwise, return false. True if the array has at least one valid partition. Okay. I don't need to partition it as well. I just need to return true if it has at least one of these partitions. Beautiful. Yeah, it's true because 4 4 4 and then even I have 4 5 6. That can be. Okay, so just to check that, okay, the partition is right. Probably like 4 4 4 and then 5 6 could be there, but it should be having 3. In this case, it could have been 1 1, but no, this 1 2 is not satisfied. Triple 4 5 6. So triple 4 5 6. What I can think of now is I can divide this or map this thing as follows: three number of contiguous elements, then some random number, and then so on this will go. So this is what the configuration will look like from this. So I'll take it 3 here, right? So it's good. You can have 4 4 4. Great. Hmm. Now once I'm like, okay, this is great. Last, I'll keep track of previously. What did I consider? Was it some random increasing value? I'll keep previously. Was it some increasing value? or same value. So in this case, I see my previous is keep पीछे वाला same value था. Now I have some random numbers, bunch of random numbers. That too, bunch of random numbers. That's 5 and 6, right? So two things here. There's some numbers which are xxx, and then we have something like 5, 6. Let's say we have something like uh, 2, 3, and then x and x. So what can I do for this? I can do something like this. Keep there. What do I say? Two possibilities for this. That firstly, I pair this up as xxx. First possibility is write this as xxx. Then let's say 2, 3x followed by that x. But that's not possible. I mean, this is one possible. Second one is I can have this as xx and then let's say x23 followed by xx. This is valid. But for this to be valid, this x needs to be 1. This goes 1, 1, 1, 2, 3, and this x would be like a 9, 9. Great. So, okay, what if this is something like this? X, 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 2, 3, 4, X, X, X. What to do now? I can have simply these three x's together, 2, 3, 4 together, and then all of this together. So by default, I'll greedily go for 4, 4, and then 4, 5, 6. What if this was like this? 8, 8. So greedily, if I went for this, I cannot go for this. It's wrong. I should be having this and then this. I need to decide key if it's x x x x x. Should I take all of those threes or I should take only these two? Well, let's see the other one. I hope so. My longest ideal subsequence. You're given a string s. You're given a string s consisting of lowercase letters and an integer k. We call a string T ideal if the following conditions are asserted. T is subsequence of the string S. The absolute difference is in the alphabet order of every two adjacent letters and T is less than or equal to K. Okay, one second. So give the string S considered as an answer K. We call a string T ideal if the following conditions is subsequence of the string S. So the subsequence, which means it can be the entire string S or it can be the entire string S or it can be simply a small subsequence or substring of S. Absolute difference in the order of every two adjacent letters T is less than or equal to K. Done. Return the length of the longest ideal subsequence means what? So single string will graph from someone change the order of the remaining characters. Okay. So so A B C D का subsequence can be AD. It's not substring. It's subsequence. A second is a string that can be from another string but someone no characters without changing the order of the remaining characters. Note that the alphabet order is not cyclic. Hmm. Also here the terms length is 10 to the power 5 now. Okay, anyways. The order is not cyclic. For example, the absolute difference the order of A and Z is 25, not 1. Mm-hmm. Absolute difference between A and Z is 25. So, what does this mean? This will mean the ORD of A minus ORD of Z, but again, an absolute of this. It's 25 makes sense. ACFGBD, ACFGBD. Okay, so ACFGBD. Case 2, and this is the string S. So, okay. So, A or C में क्या है? A, B, C. So, A, C I can have 1. Then with C I can have B, D, E, F. Huh? Then with B I can have B. So, A, C, B, D is one of the answers which is of length 4. A, C, B, D. The length of the string is 4, so 4 is return. Note that A, C, F, G, B, D is not real because C and F have a difference of 3 in alphabetic order. Okay. A, B, C, D. So, obviously the answer is 4 because it's all in one go. So, the length of the string is 4. S dot length is 25 and K is 25. Okay. Ideal string. So, what can be the case here that if I'm at a current character, let's say my current character is ACFGBD, right? So ACFGBD. This is what my string is, and my K value is 2. So what I'm looking forward to is, if this is the information I'm given, then maybe I have the option to include this A into my current string or not include it. Then if I'm at C, I have the option to include it or not include it. That would be now in AC again. I can have ACF, and like this will continue, right? This will continue. So I can even get something like A, include C, exclude F, exclude G, then when I include B, then when I include D, and then so on. This will continue. Again, there's a little bit of mathematics involved here. The reason being because like I know beforehand ki K is 2, so I have to put this to use. Maybe something like a BFS can be useful. So ACFGBD can be converted to ACFGBD. So like we know A, B, C, D, E, F, G, H, I, L, so on. 1, 2, 3, 4, 6. This can convert to 1, 3. F is what? 6. G is what? B, C, D, E, F, G. 7. B is 2. D is 4. Right? So I should know beforehand that from A where can I. So I know that from beforehand that from A I can maybe go to 3, 2, and that's it, right? 3 and 2. So why don't I start in that way? Again, I know from C I can go to A, but I won't do that because A is before C. So from C straight away I can go to 2. So this is more of something like this key. If I am at a current index, then maybe I have the option to go from there to let's say 3. Then from 3 I'll simply go to 2. Why should I not go there? Because this is irrelevant to me. Let's say A. I can form AC, I can form AB, and that's it. Now, when I go from C, I can form, I know last element is C and I know last element is B here. So if the element ending at C, I can form better, right? So initially this is 1, but with this I have 2. So since this was better, I took it. That's it. And I'll be a little greedy here. Let's have it in a priority queue. Let's say not min, but like let's say maximum heap. Currently like C with 2 will be at top and B with 2 will be at top. Okay. Now with C as 2, with C as something like 2, I can go for any of these B and D's, right? So I can, with C, I can pair up C, B, and then C, D, if I'm not wrong, A, B, C, and C, D, yes. But if I pair it up with B, what's going to happen is that in the end, this will be B updated to 3, and then probably D updated to 3. So this will look something like this, keep B में 3 and 3. Then from B onwards, I can go to, let's say, D. So PD and then D4 comes up, right? Yeah. What can we do here? CFGPT. ACFGPT. What if there was something like this? So this will contain what? Max was initially 1, then it became 2. So P got removed. And with this P, I can't remove it. With W, I can go to X. So remove it, get X stop. With X, I can go to Y. Let's say case 4. Then I've been sorting X, Y, Z here now. Then with X, I can go to Y, Z. So automatically Y with 3 and Z with 3 comes up. With Y, I can go to Z. So Z with 4 comes up. Once I get 4, I have did this. But I already know, okay, for Z3, I have a better answer. I'll skip it. Y, I have a better answer. Skip it, skip it, skip it, skip it, skip it. So that's the answer. Okay. So apart from this, I have to store the address as well. I mean the place as well, because A can be here now. Something like A0 occurring once, A n minus 1 occurring once, B1 occurring once, and so on. This will continue. So I will store. Now, I know I can go from this A to this A or this B if the index of any one of these is probably greater than the current index CID. From this A I can go to from A comma 0 I can go to A at n minus 1th location and B at 1th location. But this does not mean that I'll be able to go from B to A. And K can be at 25, right? So if I'm at A, I'll look in proximity of plus 25, plus 25 आगे पीछे, right? And uh, on that note, maybe I'll be able to find because let's say 20 at 20 some vector x is there. So how do I find x? Well, uh, uh, Well, in my hash map, I'll check key if a character with 20 is existing. Yeah, it's existing. Let's say X, but it's at which location? I'll check. Let's say it is at location. This is Y. This is at Y plus 5. So it's at Y plus 5. I'll take it. But with A20, only X can be there, right? So there can be multiple X's. There can be one way key. So like result is going to be for function. In those cases can be something, but let's see. Let's say key is let's see that key. In that case, I can probably take this, right? Key or S of I. Then I can take it. If I'm taking it, then I'm taking one more. to the next index. It's 1 and S A followed by previous. Previous is going to be S of IDX, not A. S1 and S A. Previous will be previous itself. And I can kind of memorize this using this. Memorize using current and previous values. Okay, so like that, I can probably return a maximum of 5 date of a faceless would be very simple. If I take such a key value and then return 0 because that makes sense. Let's try to run this thing. Answer is 6, which is absolutely wrong. ACFGBT. Okay, and this thing is less than equivalent to 4 is the answer. Makes sense. ABCD click here. Well, it should be whatever that is. For example, test cases run code. 4 and 4. What if I give the input like this? Let's say AB. But here I can have something like X, Y, Z, X, Y, Z. This should be answer. This should be the answer. Will be 5. Acha, ha, 4. What if this is Z? Answer should be 5. And memoization के लिए हो सकता है, it could be that if my current which is S of IDX comma previous in DP, then will be returned DP of S of IDX previous. And DP I can just create it. Oh, I can system is the max value is max value. Submit. Oh no, some additional information which is missing. ओके, कुछ भी कितना नंबर मैंने टेक कर चुका है। उसका टेक है because that taken can be kind of memorized. Let's copy this. Answer should be 42. Answer is 35, which is wrong. उस पॉइंट तक, उस लेटर तक, उस इंडेक्स तक मैं आ चुका. And how much have I taken, right? Or could be key at this index itself. How much I have taken. Have I reached this configuration before or at this index how much I have taken? Previous as that. I'm not sure about this one. Ah, 42. TLE, yeah, makes sense. Maybe taken in previous. How much I've taken with this previous, right? Would be, not sure. Front row. It's 35. What about IDX and previous? Have I been here with this previous one? If that's the case, then kindly return the back. 42. Okay, IDX and previous might work. At this current index with the previous value, have I visited this? Great. TLE. 77 passed. 25. Okay. So taken is not required. Taken is not required at all. And is also not required. So this time one more test case passed. What can be done here? Okay, we can even do this, right? Let's say A, B, A, B, Z, Z, C. I know A to B, I scan and then I see, okay, I can even go to C. Done. And since B is visited, I won't visit it again. So I know that I can go from B to C. It's not always true. Why? Because it could be like, so I can go from C, A, and then E. So I can go from C to A because it's in that radius. Then C to A, but not, I cannot go from A to B, right? But in this case, I see that, okay, I can. So from B, maybe I can do this key. I'll be able to go to not Z, but C. So let's connect this. Then from Z, I can go to this Z. Not able to get the logic. Okay, let's see, discuss. Hmm. Hmm. Okay, it's more like this. A, B, Z, Z, C, right? When I'm selecting A, and let's say K is 2, what will happen? A का है ORD of is 1. So I'll say कि at A, ending with A, it will be answer will be A पे कितना एंड हो रहा है? 0. इनफैक्ट नॉट 0 बट लाइक A पे कितना एंड हो गया? लाइक A 1 है, उसके पीछे कितना हो गया है? 20, 90. By the way, ORD of A is going to be 97. 97 minus 2 is 95. So from 95 till, so it's taking what? The maximum of that. Okay, so max of whatever is happening from 95 till 97 inclusive. That's 0 initially, plus 1. Answer is 1. So at A the answer is 1. At B the answer is 2. At Z the answer is Acha, हाँ. So since I've not processed all of these things, this makes a lot of sense. Let's say there is something like A, B, C, and I'm encountering D. So D can be paired up with any one of A, B, or C. So I know for a fact I can pair this up with, let's say, A का पीछे का जितना elements था वो 10 था, इसका 2 है, इसका 15. So pair up with this, so answer will be 16 right now. Makes sense. Okay. Hmm. Abstract of the longest sequence which can be formed with the character having ASCII X. So so for I in range and that is S of I ASCII values ORD of current cat. So I'm gonna go from that to that, right? So for I in for let's say J in for value in range of ASCII value minus k till ASCII value plus 1 if value not in value is 0. That's a 0. So for example, SQL is 97. I'm gonna go 98 and 99, right? 7 plus 2 is same thing will follow. So can I not do this? Key I'll go to ASCII value plus k plus 1. Yeah, I did that. Then end of the day I can say key in value it's gonna be value. End of the day I'll be done. So EV. No, no, no. Scene of ASCII value, right? Done. That's a good question though. This is kind of fine, but takes toll on the time limit. This is also fine. Beautiful approach. This is more of a time complexity n into k. 25 into x.